All right, y'all. Hyperbolas in this video, and what we are going to do here is kind of talk about stretching an ellipse to the point where imagine you're holding a rubber band, okay, and you pull this rubber band so tight that it just snaps. That's what happens when you pull an ellipse so hard that it snaps into two pieces, okay? So we're going to take this ellipse like this. We're going to pull it so hard that it snaps, and it now goes like that instead, and that part goes away. That's basically what's happening with a hyperbola. We can also stretch it up and down. So there's going to be some similarities, just like with an ellipse to a circle. For example, we're going to have our h comma k is still our center. We are going to have an a squared and a b squared underneath, but this time a is the positive variable. So in ellipses, remember, it could switch back and forth depending on which direction we're opening. This one's always going to be underneath the positive variable, which, as you see, comes first. Because if you look at this example, y can be the first part. Okay. Another difference is it's minus in between them, not plus like it was for ellipses. Now, just like ellipses, it was easier to kind of explain these as we graph them. So we're going to go skip to that. And we're going to just show some things, okay? So if it's y squared minus x squared, it opens up and down. Okay, so we know that the y-axis goes up and down. So if y is positive, it's going to open up and down along the y-axis. If x is positive, so x squared minus y squared, it's going to open left and right because x-axis goes left and right. So that's how you can remember which direction they're opening. They have vertices and covertices just like the ellipse did, but since it's not connected, they don't have a minor and major axis. They have a transverse and a conjugate axis, which just helps you draw your rectangle. You have asymptotes, which are going to help you draw your hyperbola. And then you have foci, which in an ellipse, they had to be inside, so it was a squared minus b squared, because they had to stay inside of the ellipse. In a hyperbola, it's a squared plus b squared because you have to get further away from the center to get into the hyperbola. Okay, so let's just start working again like we did in the last video on ellipses because that might help us see what's going on here. First thing you must pay attention to, is it x minus y or is it y minus x? Because your center is still h comma k, which goes with your x and y. So your center for this guy is a positive 2, comma, negative 3. So I'm going to go to positive 2, negative 3, and we're just going to get this party started right now, okay? To find a is going to be what is underneath the first one. But remember, this is a squared, so this is going to be a 3. And then underneath the y, this is our b squared, which means b is going to be 4. So what we were graphing, just similar to an ellipse, a is in the x direction, so we're going to go 1, 2, 3 to the right, and 1, 2, 3 to the left. To find our b value, that is in our y direction, that is 1, 2, 3, 4 up, and that is 1, 2, 3, 4 down. Now, instead of drawing an ellipse, which is what you might be tempted to do, instead, what we do is draw a rectangle. And we do it from the corners, so it's going to look just like this. We're basically making a rectangle around where our vertices and covertices are. Okay? And then we also have, as I mentioned earlier, our diagonals that go through. And these are our asymptotes that we are going to follow in a way for our hyperbolas. Okay? So that's a lot of groundwork to start by listing. Okay? Now, just like in the ellipse, we said our vertices we graph them first, and then we read the coordinate. This is 5, -3, and it is a -1, -3. So we are not going to try to find them first. We are going to graph them just counting, and then go list them. We have 2, 1, and 2, -7 for our covertices. Okay? Now, we get to do the fun part. That's graph the actual ellipse. So in order to, the hyperbola. This is x positive. When x is positive, it opens in the direction of your x-axis, which is left and right. So what we do is kind of graph like this. This is what your hyperbola should look like. We hit the vertex, or our vertices, on the x direction, and that's what you have. So now to find your foci. It is a squared minus b squared when you are doing an ellipse, but in a hyperbola you have to go further. That's why it says it's a squared plus b squared. So we have 3 squared plus 4 squared, which is 9, plus 16, which is 25. So if c squared is equal to 25, when we square root both pieces, we get c is equal to 5. Now, just like an ellipse, it is inside of the shape. So in this case, we have 5 to the right and 5 to the left, because you have to be inside the actual hyperbola graph. So that is where your foci are, which are at 7, -3, and we are at -3, -3. Okay? So that is similarities with an ellipse, is that it's inside the shape. The difference is that you have to be further away from the center. That's why it's a squared plus b squared. Okay? I know, it's confusing. There's a lot going on. With a little practice, you're going to be just fine. Okay? If you would like to try another one, I'll give you a hint. This one opens up and down. Pay attention to the x and y. Go ahead and pause the video, give it a quick try, and then when you're ready to see the step-by-step, click play again, and we will begin. So in this case, the center is -1, 2, and we know that because you have to pay attention. This is our x, so the -1 goes in the x spot, and the 2 goes in the y spot. We don't get to change x and y just because of which one goes first. So we're going to go to -1, 2, we're going to plot a dot. Now we're going to move on to our a squared, and if a squared gives you 4, that means we know a is 2. That is opening in the y direction. This is our up and down. So we are going to go 2 up, and we are going to go 2 down. That means our vertices are at -1, 4, and at -1, 0. Our b is underneath our negative, so b squared is 25. That means our b value is 5. So if our b value is 5, we are going to go 5 in the x direction, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 to the left. And we are going to make that crazy rectangular thing again, and that is going to help us graph our hyperbola. And then we're going to draw our diagonals that go through the corners and through the center. Okay? Now, to list our covertices, that is going to give us our -6, 2, and it is going to give us 4, 2. So again, just like the previous example, I did not make anything too crazy here. All right? So we're going to do our little graph now. Our graph is y positive, so this one is going to be going up and down. because our y-axis goes up and down. So nothing different has really happened here, y'all. So now what we have to do is go find our foci again. So we have a squared plus b squared, which means we have 2 squared plus 5 squared, which means 4 plus 25 is 29. That is equal to c squared. So when we take the square root of 29, we get a distance of 5.4. So that means from the center, you have to go up 1, 2, 3, 4, 5, and then a little bit more. So that makes us at -1, comma, you went up to 7.4. I understand it's a little difficult when you are working with decimals, but that's why we're just counting. We're counting first, then listing the coordinate. This one we have to go down 5.4 from the center. So 1, 2, 3, 4, 5, and 0.4. That's going to put us down here. Sorry guys. So once we are down there, we are at -1, comma, -3.4. You do not have to list the foci before actually sketching the graph. Every time I try to make a circle or a bigger dot, it starts tweaking out on me, y'all. Sorry. Anywho, that's hyperbolas. Again, no, it's difficult, but all this stuff's laid out for you step by step. Make sure you're paying attention to where your x's and y's are, and that will help guide you through all of this. All right, that's it for this one. This is Longo, and I'm out. See you, bye.